Hello and welcome. In this video, we will be finding the Thevenin equivalent of this circuit through these terminals A and B. And the first thing we want to do is we want to find the value of VTH, which is the open circuit voltage across these terminals. And in order to do that, the first thing we do is we find the currents flowing through the circuit. We can simply do this using our mesh analysis. Now, as this circuit is, we have three meshes. We have 1, 2, 3. So if we call this current in this mesh I1, make this one I2, then this one would be I3. Now in mesh 3, it is quite obvious that the value of I3 is 3 amperes. So we already have it that I3 is 3 amperes because of the presence of the current source in the mesh. Now in our mesh 2, you can write a KVL equation there and another KVL equation in mesh 1. Proceeding to mesh 2, let's call that M2. We would have 150 into I2 minus 3, that is the current in mesh 3, plus 40 into I2 minus I1 plus 10 I2, all equal 0. Simplifying this further, we would have 200 I2, okay, minus 40 I1, all equals to 450. We can call that our first equation. And then I'll proceed to mesh 1. Proceeding to mesh 1, we can write the equation there and we would have 40 I1 minus I2 plus 8 I1 minus 300, all equals 0. Simplifying this further, we would have 48 I1 minus 40 I2 equals 300. We can call this our second equation. Solving simultaneously, we would have the value of I1 to be equals to 9.75 amperes and I2 would be equals to 4.2 amperes. Okay, 4.2 amperes would be to virtually connect a voltage source VTH across the terminals and use it to write a KVL equation in a loop, say this local loop, using the currents that we already know. Now, knowing that the current flowing through the 8 ohm resistor is I1 and the current flowing through the 10 ohm resistor is I2, we can say that VTH is equals to 8 times I1, which is 9.75 plus 10 times 4.2. With this, we will arrive at the value of VTH to be 120 volts. The next thing I want to do is we want to determine the value of RTH, which is the value of the resistance of the entire circuit when these independent power sources are turned off. Turning off these power sources, we will be left with an open circuit for this 3 ampere power source and a short circuit for this 300 volts power source. Turning off the power sources, you would have something like this, with RTH being what you would measure with an ohm meter through these terminals. Now, finding the value of RTH, we can just say that these two are in parallel with each other. So RTH is equals to 40 in parallel with 8. Then this 2 together would be in series with this 10 ohm, so plus 10. Then all together they would be in parallel with this 150 ohm, in parallel with 150 ohms. And we'll have that as 40 times 8 divided by 48 plus 10, okay, in parallel with 150, and we would have that to be equals to 16.67 in parallel with 150, and that would be equals to 16.67 times 150 plus 16.67 plus 150, and that would be equals to 15 ohms. And with this information we can draw out our Thevenin equivalent. Thevenin equivalence will look something like this, with this be VTH, and VTH is 120 volts, and RTH is 15 ohms, so it will be 15 ohms. And this is what it will look like. This entire circuit will look like through these terminals A and B. Thank you for watching. Don't forget to hit the like button and subscribe. See you next time. Bye.